All right, chapter 4.5 is on universal quantum gates, which is a very fun topic. We've seen classical universal gates, and we had a few examples. So some examples of classical universal gate sets. Do you remember these? We had, for example, and XOR and NOT. We had just NAND was universal. And remember, implicitly, we're allowed to do operations like fan out, swap, crossover, and so on and so forth. And we also had on quiz 2, most of you proved correctly that the Toffoli gate is universal, and that's one of the ones that's reversible. So we had some irreversible gate sets. We had some reversible gate sets. I think most of you got it on the quiz, by the way, but how do you show Toffoli is universal? Set the target bit to 1, and that'll give you the NAND. So that was the trick there. Something very interesting, although Toffoli is universal for classical computing, it's not universal for quantum computing. Can you see why that is? There's no way, for example, that Toffoli is going to be able to generate a superposition of states. It inputs a classical, it inputs a computational basis state, and it outputs a computational basis state. Okay, that's one way to see it. Also, all the entries of the matrix for Toffoli are real valued. There's no way to get any negative numbers. There's no way to get any complex numbers. So it's a really interesting thing. Toffoli is universal for classical computing, but not for quantum computing. Toffoli is not universal for quantum computing. What does this mean? This means that classical computing is a subset of quantum computing, right? Toffoli is a valid quantum gate. So since it's universal for classical computing, I can do any classical computation that I want on a quantum computer. But there's going to be other things that we can do, right? Toffoli is not going to be able to generate, superposition states, negative numbers, complex numbers. So there's more on quantum computers that we can do than on classical computers. It's a very interesting thing. So another way to say this, I'll write down both since they're important. Quantum computing subsumes classical computing. In other words, classical computing is a subset of quantum computing.